Unit 7, Target 5. I can represent large and small numbers in scientific notation. Scientific notation is going to be in this format, where we have a number, a decimal, other numbers, times 10 to an exponent. In class, we went through this little cheer where we said first number, decimal, rest of them. And the rest of them could be more than one number. Times 10 to the exponent. And this exponent will help tell us if it is a large or a small number, and it'll help tell us how far to move the decimal. Let me give you a couple examples. If I take standard notation of 215,000 and I want to write it into scientific notation, I go ahead and follow my cheer, first number, 2, decimal, the rest of them. Now the rest of them is going to be the significant digits that are not zeros. So in this case I will have a 1, 5 times 10 to an exponent. Now our exponent is going to be determined by how far we have to move the decimal. So if I have the decimal after the 2, I would have had to move the decimal 1, 2, 3, 4, 5 places to the right, so my exponent will be a positive 5. And as I said earlier, this, whether it's positive or negative, is going to help tell us whether it's a large number or a small number. For our larger numbers, we are going to have a positive number. For our smaller numbers, we're going to end up with a negative, but I'll show you an example of that in a minute. Let's do another one. We have 130,400,000. First number, decimal, the rest of them, the rest of the significant digits is 304, times 10 to an exponent. Our exponent here will be 1, 2, 3, 4, 5, 6, 7, 8, because I moved the decimal 8 places. Down here, same cheer, we do first number is a 3, decimal, the rest of them. So we're going to put our decimal right there, times 10 to an exponent. Now, because this is going to be a small number, I do know my exponent is going to be negative. That's going to make the decimal move this direction. And now I have to count 1, 2, 3, 4, 5, 6 places. So this is going to be 10 to the negative 6th. Go through it again here. First number, decimal, the rest of them, times 10 to an exponent. Once again, I realize my exponent is going to be negative because it's a small number, and I'm going to have to move my decimal 1, 2, 3, 4, 5 places, so this will be a negative 5. So 7.05 times 10 to the negative 5 is scientific notation for this. The other thing that you might have to do is take from scientific notation and put them into standard notation. So I have 4 examples here that are given in scientific notation. We are going to convert them to standard notation. When I do that, I'll start with writing the number, 3.5. Now, if I look at this, this positive is going to mean this number is going to get larger. So I'm going to have to move my decimal to the right 4 places. 1, 2, 3, 4. There's my new decimal. And in these places, I'm going to have to add zeros. My new number is 35,000. Once again, I will write the number that's given, 4.05. Now I'm going to look. I'm going to have a positive 7 for my exponent, so I know I'm making this number larger. And I'm going to move this decimal 7 places to the right. 1, 2, 3, 4, 5, 6, 7. Put in my zeros. And if I want to say the number, think about my commas. This would be 40,500,000. Same thing with negative exponents. I'll write my number. However, I know the negative exponent is going to make the decimal go to the left. And in this case, it's going to make it go to the left 3 places. So I'll start here and I will move it 1, 2, 3 places to the left, place my decimal, and place my zeros in. So I'll have 0.0095. And another small number, because I see the negative exponent, I have 4.07. I know that this is going to go 5 places to the left, 1, 2, 3, 4, 5. There's my new decimal. Fill in my zeros. This number will be 0.000407. So scientific notation will help us show really large numbers with a positive exponent or small numbers with a negative exponent.